ఏముందంటే నిత్యాన్ని అనబోయి అది స్పెల్లింగ్ అంటే నేను ఒక చేతిలో పేపర్ లిస్ట్ నాకు చేతిలో ఫోన్ వాటర్ బాటిల్ అంటే ఎంతసేపు పెట్టావు ఎక్కినా 1 hour వస్తుంది సరే ఎక్కినా 1 hour అవుతుందని ముందే పెట్టామా ఎక్కినా 1 hour అవుతుందని పెట్టి
So this is the topic we have completed. So now I am going to explain topic. So this is we have completed logic approaches. Then those response curve for standard and parameterization is unknown. Preparation is unknown. Okay. So now I would like to explain this one. This is the one problem. Please note down all of you. So this is a very very important. That is I'm explaining here. Consider the following data pertaining to from in gain in pounds by widgets in a fixed duration of time with the standard and test repetition of a certain diet or administered to them. So this is the heading for standard preparation, test preparation. So please note on this, unit 1, unit 2 in standard preparation and test preparation, unit 1, unit 2. So here, NI summation by I by bar. So then computation is log x equal to x bar equal to 0.1505 x bar, then test preparation 0.1505 by bar standard deviation 2.8 plus 4.2 by 2 by bar test preparation 3.2 plus 4.6 by 2. So this is. So now A pi equal A s equal to 0.8 equal to 0.2. Yes, 0.2 is equal to 0.32. Hence, A is equal to y bar is 3x bar plus AT equal to y bar T equal to B x bar T, where B is 4.65 and SB is 1.23. Now, 0.1505 minus 0.1505 plus 3.9 minus 3.5, 0.086. So, R is potential ratio. The value is 1.19. That is still equal to 0.826. SPM equal to, this is the value we obtained. Okay. So now that rapid approaches when dose response curve for standard preparation is unknown. An estimate of potency based on individual observation that vary widely is of a little use until supported by same indication of its limits of error. Standard errors of the mean tolerances can be calculated by familiar process, and these must be derived a measure of precision. Consider first the two Strohonsel's pictures alone, writing Z as a typical dose. Some of ways of deviations are used to estimate the variances of Z bar T and Z bar 2 means thus for picture 1 S Z minus Z bar 1 for picture 2 S Z minus Z bar 2 both sum of squares and degrees of freedom. Hence, the usual practice of pooling the sum of squares so as to obtain a single estimate of the variance per cat. Seems reasonable, the logical flow is disclosed. This involves writing S square sum of the two main stores by size 1 plus size 2 minus 2. Here, two variances, variance of Z1 and variance of Z2 is S square by size. The square root of this is the standard error of x bar 1 and x bar 2. The equation can be written as where ratio estimate equal to z bar 1 by z bar 2 by z bar 1. Standard error for Kepler can be calculated with the aid of commonly used approximate formula for the coefficient of variation of ratio of two independent quantities. The formula is coefficient of variation A by B whole square equal to coefficient of A whole square plus coefficient of B whole square, where coefficient of variation is defined as standard error of A by A. You know that coefficient of variation x bar equal to sigma square by n. So here we consider the formula. That's why the formula is standard error of A by A. Application of above two or leads to variance of Kepler equal to coefficient of Kepler, variance of Z bar 1 plus or square variance of Z bar 1 by x bar 2 square. So here, variance of ratio is square by variance 1 by 1 by n 1 plus r square. So this is where the number of subjects of the preparation were all equal to Z bar 2 by Z bar 1 plus or minus standard. The results of an essay or summarized by limits between is the unknown true potency is almost certain to lie, although certainty is unreliable, unachievable. So rules of calculation can ensure that the statement has a high probability of being correct. By this, we expect the system of inferences, those of confidence intervals and crucial intervals are in common use in all branches of exercise. Example, the table below shows the final doses or tolerances of three groups of cats for two tinctures of strophanthus and a preparation of ukuban. Wait. The experiential procedure was essentially as described for digital. The dose were recorded as quantities per kilogram body weight of cat. Unfortunately, the absolute device doses are not known. The tolerance was assumed to vary in preparation together than independently of body weight, provided that they were arranged that they were arranged. Excuse me. That they were and arranged in okay. So that is calculated like as this. Next one is quantal responses. Quantal responses. The quantal responses in a biological assay is usually based on two possible outcomes. A common example of the two possible outcomes in death or survival. However, there are several assays such as that of some insecticide based on the mortality of the housefly. There are three possible outcomes, namely active, morbid, and dead. There is a definite order of these outcomes. Active precedes morbid, which in turn precedes it may be more efficient to analyze the data with more than two outcomes. Then combining the outcomes into two categories. An approach to the problem based on the method of maximum likelihood has been given by Atkinson and Silve and also Bullard et al. Provides a general method of analyzing the data when one uses the probabilities, logic, or other monotone transformation. The estimates of the parameters used in the general method are obtained by minimizing the appropriate C2 expressions and have the asymptotic properties of consistency and efficiency. The latter set of authors provide a numerical example involving the housefly in insecticides. Okay, so maximal information from biopsy draws the following conclusions. One is based on empirical studies, it is advisable to utilize grades responses such as body weight, organ weight, percentage of blood sugar, or any measure that can be quantitatively expressed rather than planning or a quanta say. A quintal responses category responses into grades numbers than planning a quantal assay. 71 quantal measurements, the weight used in the probit analysis of quantal responses illustrate that a graded response provides on the average about and the average on the average about twice the information of a quantal response. Also, graded responses is more useful because the latter can be measured over a wider range than quantal response is more useful the because because the latter can be measured at a wide range than quantal responses without running into extremes. Quantal responses based on groups of animals are preferable to a series of single observation at several dose levels. Also, observations derived serially from the same animal may be 4 to 6 times as per precise. As observations made simultaneously upon different animals, if it is impossible to take replicated observation on the same animal. The use of determinants or sometimes of genetically homogeneous material is helpful in large scale assays, especially those which extend over a period of time. Some animals may die or observations may be lost. So, 1 or 2 extra animals as per group to reject and insert at random from those groups whose eventual is greater than the smallest. So, this method will yield an unbiased and balanced experiment as long as animals do not because of treatment effect. In the present study, if the percentage of subjects responding is plotted against log 10 dose, a sigmoid curve will generally be the result. A transformation is needed in order to obtain a straight line. If K dose levels are considered and the preparation of units responding as a plot of a suitable transformation of the P against log 10 dose will so the points do not all have equal weights even though the number of experiment units in each group is the same. This is the main difference between the case of quantal responses and that of quantitative response. And this is one of the example, the computational advantages of the logarithmic transformation are readily seen by application to the data of table. The following, the logarithms of the tolerances table are shown below, together with calculations leading to sum of squares of deviations. So this is Robin, this is Trophanthos 2, Trophanthos 1, preparation tolerance, and total mean, and this is divided by SXX. These are the values So now each entry has been reduced by 1.0 simply the arithmetic. This is equivalent to dividing every dose by 10.0. A change of scale that no effect on calculation and straightness. Relative potency. The symbol X is used for log dose in accordance with the convention of essentially and inner relations. As the equation log Z plus log rho equal to log Z shows homogeneity is the distribution is easy. So if a proper test of this was needed, Sparlet's test for the homogeneity of a test of variances. Testing homoscedasticity might be used. Your inspection of the sum of squares is sufficient to show that mean square errors for the here the preparation, the value is this. So each form being gadget significant even by variance ratio that makes no allowance for the selection of extremes. The variance for is therefore estimated as f is square equal to 0.00849. So next, as an observation will be used for the estimate of log density from equivalent log zx plus log rho plus log t. So the value for mixture tincture 1 related to tincture 2, where m equal to x bar 2 minus x bar 1, the value is 0.075. Moreover, the variance of m simply s squared in bracket 1 by n1 plus 1 by Kaplan 2, where it is equal to 0.00849. Okay, this is the value we obtained. Well, the assumption of m or by direct application of the redistribution from 20 degrees of freedom at alpha 0.05. So T deviates is 2.0866 and difference. Okay. Okay. So the probability of the outcome. Two. So next, please wait some time. So next, check your program. So these are the examples. Please go through this. So next one is of parameters, estimation of extreme quantiles. So the main objective of this students to learn the estimation parameter, so and extreme quantiles. So in statistics, estimation refers to process by which one makes inferences about population based on information obtained from a sample. So statisticians use sample statistics to estimate population parameters. For example, sample means are used to estimate population means. Sample proportions to estimate population proportions. An estimate of a population parameter may be expressed in two ways. Point estimate. A point estimate of a population parameter is single value of static. For example, the sample mean is a point estimate of the population mu. So similarly, the sample proportion is a point estimate of the proportion P. So stat estimate, interval estimate, an interval estimate is defined by two members between which a population parameter is said to be lie. For example, A less than X less than B, interval estimate of the one minute. One minute, please. So these are the topic as same as now I would like to explain this is polycotomus of quantal response. The quantal response is a biological assay usually based on two possible outcomes. A common example of the two possible outcomes death or survival say explained already. Now I would like to explain which is different. 1 minute, please wait. Which are similar the estimation process. Now it's a very important topic. I am going to explaining that 6 point. So this is very, very important. I am going to explain estimation of allele frequency, dominant, codominant cases, multiple alleles. So know that the concept of dominance and know the type of dominant allele. Estimation of allele frequencies. Allele frequencies for multiple alleles. Okay. So the main introduction dominance is a key concept in Mendelian inheritance and classical genetics. So letters and connect states are used to demonstrate the principles of dominance in teaching and the use of uppercase letters for dominant alleles and lowercase letters for recessive alleles is a widely followed convention. So dominant allele. A dominant allele is a variation of a gene that will produce a certain phenotype. Even in the presence of other alleles, a dominant allele typically encodes for a functioning protein. So the allele is dominant because one copy of the allele produces an enzyme to supply a cell with plenty of a given product. Some traits rely on a product being created, like pigment molecules for hair color and journals for proper cell function, and other traits that rely on a functioning and other traits really on the lack of animal or enzyme that is not functioning efficiently. The lack of the product of the enzyme creates an entirely different phenotype. When a dominant allele is completely dominant over another allele, the other allele is known as recessive. However, there are also situations of incomplete dominance and condominance. In incomplete dominance, two dominant alleles can mix to create a third phenotype, a sort of mix between two phenotypes. So think of a white and red flower alleles mixing in a heterozyte to produce a pink flower. In condominance, different alleles are expressed in different areas, creating unique pattern. Think of condominance as the spots on a cup. So to describe the allele is a dominant allele, you must reference. So dominant and recursive are just descriptions of a relationship between alleles. Some alleles of a gene compete differently with different alleles. That may be dominant to one allele and recursive to another. It all depends on the protein they create, how those proteins interact with each other, and how the entire system interacts with the environment. With the most simple examples given are purely dominant recursive relationship inheriting interactions as much as complex. So types of dominant allele. So one is dominant allele can be classified into three types: complete dominance, incomplete dominance, codominance. Complete dominance. In case of complete dominance, a dominant allele completely hides the effect of a recursive allele. This can only be seen in heterogeneous individuals. Homogeneous dominant individuals have two dominant alleles, which produces the same in homogeneous recursive individuals. No dominant allele is present, and the phenotype only reflects the action. So this is the green allele products and non-functional enzyme and no yellow pigment is created in homogeneous recursive plant. The yellow allele pigment to the is dominant to the green allele, and green allele recursive is the yellow allele. The picture below shows the cross between a heterogeneous individual on the left and a homogeneous recursive individual on the top. See the pic. So this is heterogeneous and homogeneous. So incomplete dominance. Incomplete dominance is case where dominant allele produces different enzymes, but one allele does not cover when the other in the phenotype expression. Both alleles are considered dominant alleles in relation to each other and produce an equivalent amount of the efficient physically in some flowers. The effect is that flowers are simply incomplete dominance. So now the red flowers have two copies of the red allele. That gives allele to produce enough red pigment to make a deeply red color. The allele that produces white flowers creates a non-functional allele. Without its red color, the flower appears within a individual that with two which alleles. However, the red allele is not dominant over the white allele. So because in the heterogeneous individual flowers are pink, not red. Incomplete dominance affect many different enzymes and not just the ones that control the things we see. Incomplete dominance is responsible for different organisms producing high levels, medium levels, and low levels of certain substances. So in predominance, the dominant alleles are both expressed, but they are
సర్లే సార్ సేమ్ చేస్తారు సరే ఆదివారం ఉంది ఎల్లుండి ఆదివారం ఇస్తే నాకు తీసుకుంటారు సత్యపల్లి సార్ సత్యపల్లి చెన్నై ఫంక్షన్ హాల్ యాక్సిడెంట్
1 minute, please.
వాట్సాప్లో నేను చేస్తాను ఆ మండలాలకి యూనియన్ ప్రెసిడెంట్ మెకానిక్ అయితే ఒకసారి వాళ్ళని కూడా ఇన్వైట్ చేయండి సార్ ఎలాగో బాగుంటుంది కాబట్టి ఖాళీగా ఉంటుంది కాబట్టి యూనియన్ ప్రెసిడెంట్ సండే కదా అని చెప్పి వాళ్ళు చెప్పి తీసుకొస్తారు వాళ్ళు కూడా పీపీటీ ప్రజెంటేషన్ వాళ్ళ గురించి వెళ్ళిన తర్వాత మనం
1 minute, please.
ఏంటంటే రేపు స్టాక్ డిస్పాచ్ కంపెనీ నుంచి రేపు స్టాక్ వస్తుంది ఆదివారం ఇనాగ్రేషన్ అయితే సోమవారం నేను స్టాక్ డిస్పాచ్ చేస్తాను రేపు డిస్పాచ్ ఉంది కాబట్టి స్టాక్ ఈ రోజు ఓకే సార్ లక్ష్మి గారు ఒకసారి చెప్పండి సార్ మార్కెట్ తీసుకున్నాను సార్ పార్ట్ పేమెంట్ ఒకటే ఆగింది సార్
1 minute, please.
గారితో కూడా మాట్లాడాను. నాకు కూడా ఏమన్నారంటే సరే సార్ యాక్చువల్లీ ఏంటంటే ఇంకో పక్కన మొత్తం తిరిగాము కాబట్టి మీకు నేను బాధ్యత మాట్లాడతాను. సరే అన్నాడు. తిరుగుతానండి లోపల అందరూ చెప్పండి మన మెకానిక్ ట్రాఫిక్ అందరినీ చెప్పడం కాబట్టి వస్తారు. మెకానిక్ కూడా లోపల కూడా గ్యాదర్ అయ్యాను. ఏం చూపించారు గ్యాదర్ అయ్యారు కాబట్టి చూడండి మండల డిస్ట్రిక్ట్ కూడా అక్కడ వస్తున్నారు పెద్దగా అన్నిటికీ చేయండి ఓకే చేయండి తర్వాత
1 minute, please. I am sharing the screen.
ఒకసారి మాట్లాడితే ఫోన్ మాట్లాడి మనకి కొంతమంది అనుకుంటున్నాం కాబట్టి ఇది పలానా ఐటమ్ కొంచెం ఎక్కువ అనిపిస్తుంది తగ్గిద్దామని మాట్లాడారు. సరే తీసుకొని తగ్గించంటే అప్పుడే తగ్గిస్తే చెప్పబెట్టే మార్కెట్ సరే ముగ్గురు వెళ్ళారు ఎట్లా
So this one explained. No mistake. 1 minute, please.
కనాడ్ వచ్చిందండి. కనాడ్ మొత్తం పూజలు పిలిపించారా? పూజలు పిలిపించారా? అదేలేండి సరే మాట్లాడండి ఒకసారి. అయితే ఇప్పుడు ఇంకోటి ఏంటంటే ఇప్పుడు మన కృష్ణ మందిరం అంటారు కదా ఇది పాషాది టింకరింగ్ షాప్ ఉంది కదా మన ఆటో పాషాది టింకరింగ్ షాప్ ఉంది కదా ఆ టింకరింగ్ షాప్ కంటే బిఫోర్ దానికంటే ముందు షాప్ అంటే కృష్ణారెడ్డి గారి షాపు ఒకసారి వెళ్ళండి షాప్ దగ్గరికి వెళ్ళి మన ప్రోచర్ ఉందా మీ దగ్గర కృష్ణారెడ్డి మీ దగ్గర ఇప్పుడు గోపి వాళ్ళు బైనరీ కూడా ఉంది కదా బైనరీ వాటర్ ఆ వాటర్ గోడంలో మన ఇంజనీర్ బాక్స్ శాంపిల్ బాక్స్ ఉన్నాయి అందులో బ్రోచర్లు కూడా ఉంటాయి చూడండి.
one more thing, that is, please look this rules for probability for Mendelian inheritance. Okay. And before that, I would like to explain this. We have dominant rules that we have sorted. So 1 minute, please wait.
ఓపెనింగ్ చేసేసుకొని లంచ్కి వెళ్ళిపోవచ్చు. ఈ మీటింగ్ ఇవన్నీ ప్రెజెంటేషన్ అన్నీ ముందే కానిచ్చేస్తాం. అందుకని అయితే మరి ఎండి గారు వచ్చిన తర్వాత ఆయన ఖాళీ కూర్చోబెట్టుకుని ఆయనతో కూడా కొంచెం తీయాలి కాబట్టి రెండు తీసుకుందామని ఇందులో ఒకవేళ అవకాశం ఉంటే దీపాలు రెండు తీసుకుందామా మొత్తం ఎండి గారు కానీ వాళ్ళు తీస్తారు సపరేట్ పక్కన దాన్ని కూడా డెకరేట్ చేసుకుంటాం సార్ తిరుగుతాం అట్లా చేద్దామా లేదు దీపం పెట్టి ఎండి గారు అప్పుడు స్టార్ట్ చేసేసి ఎండి గారు వచ్చిన తర్వాత ఒకే ఇచ్చి డైరెక్ట్గా ఓపెనింగ్ పెట్టేద్దామా లాంపింగ్ లేకుండా.
So estimation function, the quantile response function. So this also I would like to explain. Already we have finished the topic, this dominance rule. So that is role of the scheme. So this is quantile response expression of points and quantile response function. This I started now. Now we have finished some of the topics of this. So next one is estimation of functions of quantile response function. So suppose a number of plastic pipes of special length are subjected to impact of energies. Several levels of the response may be noted. In particular, we could record whether or not a brittle future failure has happened. Let y of x denote the response to dose level x and assume that y of x the brittle fail, taken value 0 and 1. The probability of y equal to 1, where p of x increase with the x. We will be interested in finding xp for which p of xp equal to p. So far, we have been dealing with known forms P of x. Here, we assume that P of x is unknown. This problem is closely related to Robin's macro cross, which is slightly more general, and in the following, we will review aspects of the process. Robin's model process. Given a random response y it x having the expectation of x is mx, we wish to estimate theta such that m of theta equal to alpha. So Robbins and Morrow following sequential procedure cases in an initial value u xi and y denote the response xi. Then to replace xn minus the formula xn plus 1 equal to xn minus a and y and xn minus k. So where decreasing sequence of positive constants and n tends to 0. If we stop after n iterations, then xn minus is the estimate of theta. Especially if alpha equal to 0, then the RM procedure becomes xn plus 1 equal to xn minus a in y and x. Note that xn plus 1 less than xn if y and xn greater than 0 and xn plus 1 xn greater than xn if y and xn is less than 0. An appropriate choice for A and E by N where C is optimally in some senses that will subsequently be not unreasonable to assume that for all x greater than 0, m of x less than 0 is less than 0. So Domina and Snacks and MCX study the convergence of x and the rate of convergence, the two choice of A and the asymptotic distribution X has shown that the A equal to C by N. Asymptotic distribution of x minus theta total is normal where 0 sigma square sigma by 2 c beta minus 1, where types of convergence xn square sequence of random variable mean square convergence xn is set to convergence theta. The quadratic mean limit intention to the expectation of xn minus theta square is 0 or weak convergence. Convergent probability for every epsilon greater than 0 limit at infinity, the probability of xn minus theta greater than epsilon is equal to 0. Strong convergence limit probability of limit at infinity xn equal to theta is 1. Now that 3 to 2. So definition. Stochastic approximation is concerned with produces or schemes which converges there's some values that out when the observation are subject to error due to the stochastic nature of the problem. Interesting schemes are those that are self-correcting, namely those which are errors that always tends to disappear in the limit and in which convergence to the distant value is of separate nature. Biopsy sensitivity testing or in particular the statistician is often interested in estimating a quantile of distribution function on the basis of some data, each datum being of the 0, 1 type. Let f of x equal to b metallic specimen will fracture if subjected x cycles in a figure triangle. A specimen tested in such a way will represent an observation and takes either 0 or 1. And the problem in test would be to estimate the number of cycles x such that are given f of x is a. So probability analysis up and down procedures depend upon functional form of f. For real x, yx responses to an experimental carried out a control level x and have the unknown distribution function is a given x and regression function m of x the expectation of y of x minus infinity y into differentiation of y of x. That's the no knowledge of mx and h of x is also Robin and monophysician. Let A be given a real number. So this is
మీ దగ్గర అగ్రిమెంట్ ఉంది కదా ఆయన సత్తుపల్లిలో చేస్తాను సీఎం చెప్పాడు పల్లెల్లో ఉంటే ఈవినింగ్ ఎటువంటి
Robbins and Monroe procedure. Let alpha be a given real number. We wish to estimate the root of the equation mx equal to a, where we assume the existence of a unique root. One can use Newton's method provided the form of the function m is known. If at Ulf's process, we wish to find theta such that m of theta is maximum. Properties of interest. To find a recursion for x1, x2, etc., xn, and to show convergence of xn, that is to show that limit n tends to infinity xn minus expectation of xn minus theta whole square is 0. So that is probability of limit xn equal to theta equal to 1. Asymptotic normality of xn or mfxn. Confidence interval for theta, optimal stopping rule. Robin Monroe proved the following theorems. If A and B a sequence of positive constants such that 0 less than summation a square less than infinity and summation an by a1 plus a2 etc. n minus equal to alpha, which implied by the condition summation an equal to infinity. Probability of modulus yx less than or equal to c equal to minus infinity to c. So differentiation by given x equal to 1. For all x, some finite c, and for some greater than 0, capital mx less than or equal to alpha minus delta. For x less than zeta and mx greater than or equal for all x. Some finite c and some delta greater than 0, mx less than or equal to alpha minus delta for x less than theta, and m of x greater than or equal to alpha plus delta for x greater than theta. Then the sequence xn plus 1 equal to xn plus an into alpha minus yn converges in quartic mean and ends in probability. So limit n tends to the bn equal to limit n tends to infinity expression of xn minus theta whole square is 0, where xn tends to theta in probability. So 1 and 2 theorem, 1 holds mx is non-decreasing. M of theta equal to alpha, m of m dash theta is greater than 0, then limit n tends to infinity bn is 0. Let f of x be distribution function such that f of theta equal to alpha, where 0 less than alpha less than 1. Differentiation of f theta is greater than 0. Where Zn be a sequence of independent random variables such that probability of Zn less than or equal to x equal to capital F of x. So values of x, and we observe only the values y, where y is 1, x and response 0, z greater. So there is no response. Next one is Bloom's condition. This is a very important. This condition is m of x less than or equal to c plus d of modulus of x for some d equal to 0. Sigma square minus infinity modulus y minus mx whole square. So y by differentiation y by x less than equal to sigma square less than infinity, where m of x less than alpha when x less than theta, m of x greater than alpha when x greater than theta. So infimum delta 1 greater than equal to less than equal to x minus theta less than equal to theta 2, where mx minus theta is greater than 0. For every delta 1, delta 2, under the above assumptions, Blum showed that probability limit intention for x and theta equal to 1. Notice that assumption 4 allows possibility of mx tends to alpha, where mod x tends to infinity. And in such a case, one would expect that there might be positive probability of mod x and converges to infinity. So what he has shown that under the conditions of Bloom x and converges in the mean to theta. So that one. So the one shows these conditions. So these are the topics we have explained, and tomorrow we are going to explain one more topic. Thank you.
ఎక్కడికి ఎప్పుడు పోవాలి